This will be Geometry Section 0.3. We will continue with the algebra stuff that we have been practicing the last couple of days, and this will be our last thing. This is going to be solving quadratic equations. Now, this was probably one of the most difficult things for you last year in algebra, and you kind of took 3 separate days to do the 3 methods that we're going to do in one day today, since it is just a review for you. Solving quadratic equations, we have multiple ways. In fact, today I'm going to show you 3. There's actually a 4th that you didn't quite get to last year in algebra, but I'm not going to show you that way because the other 3 will suffice with what we need. So when solving a quadratic equation, you are trying to find the x-intercept, or I should say intercepts possibly, and that's where it crosses the x-axis. Okay. So if we look at the parabola, now in the last class we worked with graphing these, and we actually saw these, but we didn't really talk about them. We looked at where does it cross the x-axis. Those are what we call solutions in quadratic equations. So when we look at this graph, there's 2 of them. This graph crosses right here, the x-axis, and it crosses the x-axis right here. So we would say we have 2 solutions when x is 0 and when x is 4, because that's where they cross the x-axis. We could also put those as ordered pairs at 0, 0 and 4, 0. Looking at these, when the y values on both of these are always going to be 0 in our solutions of quadratic equations. All right, so that's what a solution is. Now last year in algebra you talked about having 2 solutions. We could also possibly have just 1 solution where that graph comes down, hits perfectly, and then goes right back up. This would be a case where we have 1 solution, and our solution right there would be at -5, 0. You also talked last year about having possibly no solutions. That would be something like this. If we look at this graph right here, it's in quadrant 4 down here, and it opens down, so that graph will never be able to come up here and reach the x-axis. So this would be a case where there are no real solutions, and you talked about that last year in algebra. And you also looked at how could you tell, and you looked at something called a discriminant, which we're not going to get into today. Alright, so let's move on. We'll look at this. We're going to relearn the 3 ways that we solved quadratic equations last year. And guys, we're going to do them wham bam real quick in one day, since this was one of the, you probably did this halfway through second semester last year. We're going to learn the square root method. Okay, this is probably the easiest. Okay, the bad thing is this does not work. This doesn't work with a b value. So if we have an equation, this only works when you have something like this. Y equals 2x squared minus 4. Okay, notice there's an a value, there's a c value, but there is no x. There's no x value there. Okay, so it doesn't work when you have a b value other than 0 or an x value there. Okay, that's the only time that one works. So that one's not real handy. It's really easy to use, but not real handy. Okay, then we're going to talk about factoring, and when we solve by factoring, we're also going to talk about the zero product property. Very, very simple concept when we get there. Factoring would be the harder part. Zero product property sounds complicated, but it's not. And then the good old quadratic formula, and some of you, once I start this, you may be able to finish it. The quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so there's the quadratic formula where we take our a value, our b value, our c value, and we substitute it all in here. Now the nice thing about the quadratic formula, if we have solutions, we can use this guy. Okay, the bad thing about the square root method, doesn't work all the time. The bad thing about factoring, if you look at the number of 13, are there factors of 13? No. So some quadratic equations are not factorable. So normally my go-to guy would be this, because we can always do that. If there's a solution to be found, we can find it. If there's not one to be found, we can find that there is not one to find. All right, so that's what's kind of nice about the quadratic formula. All right, so let's go through here. We're going to start with, let's just use the square root method. Now, if you look at these guys, the first thing that we always need to do when we're solving these, no matter what, is here's the numero uno thing, the number 1 thing that we always have to do. We need to make sure that the equation is equal to 0. Alright? Now that's going to change for these guys because if we look at this, this would be x squared minus 25 equals 0. Okay? So we would have it equal to 0 and we could solve it. Notice there's no y. The y value, if we look at our old school y equals ax squared plus bx plus c, the y value is 0. I mentioned that not too long ago that, hey, when we have our solutions, our y value is 0. So if I do have a y there, I'm substituting 0 for y so we can solve that. Right? Now on this one, what we would do is we'd add 25 using the square root method, and we'd go x squared equals 25. Now we know this. You did this in Pythagorean theorem probably last year, that to get rid of the squared, what we would do is we would take the square root and the square root of that side, and we would find that, hey, the square root of 5 is 5. There's a catch here. There's a catch here. Because there are actually two numbers. Here's kind of my explanation of this. There are two numbers that I can square and get positive 25. One of them is 5. The other one is negative 5, because if I took negative 5 and squared it, I still get positive 25. So when we do this little process of square rooting it to solve it, we're going to have two answers. Now here's how we show that. Positive and negative 5. Okay. If you wanted to, you could write 5 and negative 5, but I just like to use the plus minus symbol. Okay. If you just remember the quadratic formula, we just showed you that. So let's go here. We're going to solve this guy. So we're going to go ahead. There's no b value. There's no x in there. So that's why we can do this, because there is no x value there. So we're just going to square root it. Square root it. We all know that the square root of 49 is 7. But remember, there are two numbers that I can square and get 49. 7 and negative 7. Now in this guy, we got some work to do first to get this ready for the square root method. There's still no x value. There's no b. Alright, so when we do this, the first thing we need to do is subtract that 5 over. So subtract 5 over, subtract 5 over, that's 16. Now we have it all set up for the square root method. So to get rid of that square, we can square root. Square root. So that's gone. So what we have is the square root of 16, which is 4, because 4 times 4 is 16. But remember, we have two answers, positive and negative 4. Alright, so that's the square root method. Very, very simple. Basic algebra skill there. But remember, not the best way most of the time, because most of the time we're going to have a b value there. So let's move on to this one. Number 4, we just go ahead and square root. Square root, we're ready to roll. Square root, square root. So we have x equals positive and negative square root of 8. Now, if you left that, that's fine. If you went to decimal form, I'm fine with that as well. So what you could do, I'm going to show you two different ways to write your answer. Square root of 8 is 2.8. So you could go, hey, x is approximately positive and negative 2.8. You also did this in algebra last year where we worked on simplifying those radicals. Here are your perfect squares: 9, 16, 25, 36, 49. 4 is a perfect square factor of 8, meaning I could write this as the square root of 4 times the square root of 2, and that's still the square root of 8. So if we wanted to write this in simplified and keep it nice and pretty, this would be positive and negative. The square root of 4 is 2. The square root of 2 is not pretty, so we would leave that. So what this is a decimal approximation. This is called simplified radical form. I show you that now because we're going to do more of that. Instead of writing our answers, it's about 2.8, it's about 2.828, something forever and ever, amen. This one is still exact because I haven't rounded anything yet. Okay, all right, so either answer is fine for now, but we'll get to the point where we're going to look for those exact answers like that. Okay, let's go on to number 5. Number 5 is not quite ready. It's got some work that needs to be done first. Okay, so this is just a basic algebra like we started day 1. We're going to subtract 3, do that whole mess there. So we get 2x squared equals 242. Now we have this times 2, so let's get rid of that times 2. Not the last time we're going to do that. So we have x squared equals 121. Now we're finally to that point where we can use that square root method. Square root, square root. Now remember, we have two answers. We have the square root of 121 is 11, but we also have positive and negative 11 there. So there's your two answers. And again, the reason this works is because there is no b value. There's not that x there that complicates things. All right. So let's look at the next one here, where we have x squared equals negative 4. So what we do here is we square root here, square root here. You do this, and then if you throw this in your calculator, the square root of negative 4, throw that in your calculator real quick. Your calculator's going to probably kind of laugh at you. So say, error, you can't do that. The reason is you can't square root a number. You can't square root a negative number. If you look at it this, there is no way, there are no real numbers that you could take, square them, and get a negative number. I said there's no real numbers. There are some unreal numbers yet. You don't know them, so we're not going to deal with them. So all we're going to do here is go NRS. Now what the NRS stands for is no real solutions. There is not a real number that works for this. There are some unreal ones, some imaginary ones, but you don't know that yet, so don't worry about it. Now, that's solving. Now notice on all of these equations that we just solved, there is no x by itself. There's x squared. That's why we call it the square root method. We square to get rid of the square root, but there's no x value. Now we're going to look at ones, let's say that there is an x value. So now we have our nice, pretty quadratic equation here. Now notice there is no y because we substituted 0 for y because we're finding solutions. Go back. When we find solutions, we're finding the x-intercepts. The y value is 0. That's why we keep substituting 0 in for y on these. Okay. Now, when we do this, we're going to factor these guys. Okay. There's two cases of this. The two cases of this is when a value is 1, that's easier. Okay. When a is not 1, that was hard. That was a harder way. Not bad, but harder. Okay. So let's look at number 7 right here. Now the first thing we always need to make sure of is that that a value, or that equation, is equal to 0. Okay, so we don't want a constant on the opposite side of my variable here. I want everything on the same side and 0 over here. So sometimes we may have to do a little bit of prep work to get it to look like this. All right, so let's look at number 7. Notice our a value is 1, so this is the easier way. Now, if this is factorable, now remember not all these are factorable, but if it is, we're going to look at the c value. I'm going to write my factors of c. 3 and 1. That's it because it's a prime number, but you also got to think we have negative 3 and negative 1. Okay, so what we're going to do is we're going to look at this, and these factors, we're looking for the factors of c that add to b. And the pair that we have that adds to negative 4 is this pair right here. Now this is how easy this is going to be. We're going to split this up. We're going to go x minus 3, x minus 1 equals 0. Right there, we've got it factored. Now, if you remember this little acronym from last year, because you did this last year, oh, we didn't? Yeah, you did. You did this last year. FOIL, where you went first, outside, inside, and last, and you FOILed that back out, you would get right back to that equation right there. Okay. So what we have now is a nice, pretty binomial times a binomial equal to 0. So I mentioned a zero product property earlier. If we have two values that multiply together to get 0, that means that one or both of those values need to be 0. So x either needs to be 0 or y equals needs to be equal to 0 or both of them. So we can use that concept right here. Meaning, since this is equal to 0, this guy needs to be 0 or this guy needs to be 0. So very easily, what value of x makes this guy 0? Well, 3 does. Because if this is 3, that's 3 minus 3. So x is equal to 3. And what value of x makes this equal to 0? Well, 1. So my equation, my solutions here are at 3 and 1. Now, if we look at this, this graph opens up because the y value is 1. And it crosses the axis at 1 and 3. So I know that that graph looks something like this. Now I'm missing a very critical point from here, and that would be that vertex. We could do that opposite of b over 2a and find that, okay? But I'm not going to. We don't need it. We just need to solve it, okay? So let's go to the next one. Number 8, y squared minus 5y plus 4. So again, it opens up. We could go through the opposite of b over 2a to find the vertex. But we want to see if this is factorable, okay? So first thing we check is a is 1. A is 1. This is the quick way, okay? We have a b value. We can't use the square root method that we just learned we just learned to do this. We have to factor it. Okay. So let's go over here. We're going to look for our factors of c to find the factors of c that add to b. So my factors of c are 4 and 1, but we also have negative 4 and negative 1. We have 2 and 2. We also have negative 2 and negative 2. So what pair here adds to negative 5? That would be these two guys right here. So we're going to go ahead, being my a value is 1, we're going to split it up. We're going to have y minus 4 and y minus 1. Again, if we wanted to double check this real quick, we could FOIL that first, outside, inside, last, and we would actually get right back to that guy. So my solutions are going to be now, what value makes this 0? Well, 4. And what value makes that 0? 1. So there's your solution. So we know that that quadratic equation would cross the x-axis at 4 and 1. All right. So let's do another one of those nice easy ones where, hey, the a value is 1 and then we get some nice pretty factors here. Okay. So again, the first thing we need to check is a value is 1. Good. So what we need to do is find factors of 9 that add to 10. So my factors of 9 are 9 and 1, negative 9 and negative 1. So what pair there adds to 10? Well, that would be those two. So we're going to go m, I'm going to flip-flop here, m plus 1 and m plus 9, and that equals 0. Now, because that equals 0, one of these or both of them have to be 0. So what value of m makes this part 0? Negative 1, because negative 1 plus 1 is 0. And what value of m makes this 0? Well, that would be negative 9. So there's your two solutions. So again, that would be a parabola, opens up, crosses the x-axis at negative 1 and negative 9. Alright, let's move on. Now we're going to get a little harder here, because if you look at this, this one is messed up because it's not equal to 0. So let's put it equal to 0. So we're going to go, I'm going to move the x over and the 2 over, so I'm going to go x squared. I'm going to go minus x minus 2 equals 0. Now we're ready to roll. Now we look at our a value. A value is 1. Easy way. So we're going to look at our factors of negative 2. We have negative 2 and 1. Now with that same pair, we also have 2 and negative 1. And that's it. So we're looking for the pair that adds to negative 1 right there. That would be these guys. So when we rewrite this, it's going to be x minus 2, x plus 1 equals 0. So we look at this, x is going to be 2 and negative 1. There's your two solutions. Right? Let's go to number 12. I'm going to skip 11. Number 12, same thing. A value is 1. It's equal to 0. Those are our two checks we need to start immediately. Is it equal to 0? Okay. What's the a value? A value is 1. So we need to find factors of 36 that add to negative 12. Okay, so we have 36 and 1. Remember, we also have negative 36 and negative 1. We'll work our way up. We have 2 and 18. We also have negative 18 and negative 2. Remember, we're looking for them to add to negative 12. We have 3 and 12. We also have negative 12 and negative 3. We have 4, 9, negative 4, negative 9. We have 6 and 6. We have negative 6 and negative 6. Oh my goodness, all that work, and the pair that finally adds to negative 12 is the last pair we did. Okay, so we rewrite this as x minus 6, x minus 6 equals 0. So my solution, now if you look at this, it's 6 here and it's 6 here. So we have two solutions of 6, but I'm just going to write it once. X is 6. This is one of those goofy cases where this graph does not cross at two different places. 1, 2, 3, 4, 5, 6. This graph opens up, hits once, and goes right back up. So this is a case where we don't have two solutions. We only have one solution. Okay. All right, let's move on to number 13 now. Now this is a goofy guy because we are equal to 0. That's our first check. A, it's equal to 0. Second check is, what's the a value? The a value here is not 1. Oh boy, we have more work to do here. Okay, so this is more difficult. So let's start. We're going to take a times c. The direction said take a times c 8 times negative 3, you get negative 24. Now we're kind of doing the same process. All right, we're going to look at, all right, what are the factors of negative 24 that add to 2? So we have negative 24 and 1, 24 and negative 1. We have 2 and negative 12. We have 12, negative 12, and, positive 12 and negative 2. All the while looking for them to add to 2. We have 3, negative 8, 8, negative 3, 4, negative 6, 6, negative 4, 5, no, so we're back to 6, we're good, we got them all. So what pair adds to positive 2? These guys. Now this one's different. What we need to do now is we need to look, we've got our pair, we've got negative 6 and negative 4, or 6 and negative 4. That's the pair we're going to use. Oops. 6 and negative 4. We can't just go and rewrite this right now. What we're going to do is we're going to partner these up with pairs that work better. So if we look at our 8, which one works better with an 8, a 6 or a 4? Well, which one works better with a 3, a 6 or a 4? So this 4 works better with this 8. So when I rewrite this, I've got to rewrite it all the way out. I'm going to go 8x squared minus 4x. That's a positive, so I'm going to go plus 6x minus 3 equals 0. Right? Now what we're going to do is we're going to group these guys. Alright? So I'm going to do this. And I'm going to look for that common factor here. I'm going to look for that common factor here. The common factor between 8x squared and 4x is not just 4. I can pull a 4 out, but I'm going to take an x with it. Okay? So here I had 8. I factored 4 out. I'm left with 2. Here I had 2 x's, and I took 1 out, so I still have an x here. That's a minus. Here I had 4x, and I factored the whole 4x out. I can't put 0, because 4x times 0 is not 4x. 4x times 1 is. Okay? So now what we could do a quick check right here. If we went 4x times 2x, it's 8x squared. If we went 4x times negative 1, it would be negative 4x. So we know we're right back to where we were. Let's continue. So we have a plus. What's our common factor here of 6x and minus 3? That's a 3, so I'm going to pull a 3 out. I had 6x. I pulled 3 out. Now notice, I can't pull an x out of this because this guy doesn't have an x. So I'm left with 2x minus, I had 3, I factored 3 out, I'm left with 1. Hopefully you see this. Oh, that's the same. If you do this right, that's what's going to be the case. That will always be the same. And we have this equals 0. So now what I'm going to do, guys, is I'm going to regroup this again. I'm going to factor this 2x minus 1 out. Meaning I'm going to take this 2x minus 1 away from there. I'm going to take it away from there. And if we look at that, what's left? 4x plus 3 equals 0. So now we can still use that same 0 product property here, but it's not as obvious. So what I'm going to do is I'm going to write two kind of mini side equations over here. This needs to equal 0. So we go, alright, 2x minus 1, let's see, needs to equal 0. Then we can do our basic algebra skills, add 1 over, divide by 2, divide by 2. So the value of x that makes this part 0 right here is 1/2, because 2 times 1/2 is 1, 1 minus 1 is 0. So we know that x equals 1/2. And do the same thing over here. Let's do mini equation, side equation here. 4x plus 3 equals 0. Subtract 3 over, we get 4x equals negative 3. Divide by 4. X equals negative 3/4. So there's our two solutions. Not as pretty on this, and that's probably because we had that a value that wasn't 1. Okay? So we have an a value of 1. It's harder, it's more difficult, but follow those steps. Okay? Let's go to number 15. So number 15. Number 15, we have 2d squared minus 13d minus 7. Let's go through our checks here. Check, equal to 0. Check. Second thing we check, what's the a value? Oh man, the a value is not 1. Man, when the a value is 1, it's so much easier, but the a value is not 1 here, so we got a little bit more work to do. So let's do that math. So we have to take 2 times negative 7, we get negative 14. We took a times c. A times c was 2 times negative 7, which is negative 14. we need to find those factors of negative 14 that add to negative 13. So while we're factoring this, pay attention. Negative 14 and 1, but we also have 14 and negative 1. We're already done with this because this pair right here adds to negative 13. We could have went 2 and negative 7, 7, negative 2, but we didn't have to. All right. So again, when we break this up, we look at this. Does 14 work better with the 2 or better with the 7? I'm going to put that 14 with that 7. So I'm going to go 2d squared plus 1d plus, and notice I'm going to do plus, and I'm going to do negative 14d for a reason, minus 7 equals 0. Okay, so now the reason we can do this is this negative 13d is the same as what these two are put together. So we haven't really changed the way, the value of it, we just changed the way it kind of looked. It's like saying 2 plus 3 is the same as 5. They're different things, they just look different, but they're the same thing. So now we're going to group these two guys. Now remember, when we factor out here, we're going to get some parentheses that are the same. Just like we had back here, we had these two guys that were the same. Okay, so that's what we're looking for. So we look for a common factor of 2d squared and 1d. And there's no common factor between 2 and 1 except for 1. There is a common factor between d squared and d. I can pull a d out, and I'm left with 2d. Here I'm just left with 1. Okay, because I took the d away from that 1, I'm left with 1. So remember, what should happen over here is I should have 2d plus 1 if I did that right. So let's see, what's our common factor of negative 14d and negative 7? I'm going to do the negative 7. Now if we distribute and look, that would be 2d squared. We could double check this real quick. This would be 2d squared. That would be d, just like back. This would be negative 14d, and that would be negative 7. So we'd be right back to where we were. But we don't want to go backwards, we want to go forwards. So my next step would be to, alright, let's pull this out and rewrite it. So I'm going to factor that out, 2d plus 1. And once I take that away from both of those, what's left? D minus 7 equals 0. Now this one's nice and easy. What value of d makes that 0? Well, 7, because 7 minus 7 is 0. That's not the case over here. So we got to do that little side equation like we did last time. We have to say, alright, 2d plus 1. We need that to check that. When is that equal to 0? So we'd subtract 1. We'd get 2d equals negative 1, divide by 2. Divide by 2. So there it is. There's your other solution, negative 1/2. So again, what we found is this parabola crosses over here at 7, and right here at negative 1/2 is where that's going to cross and opens up, and we're good to go. So that's what we found. Again, we're missing that critical point of the vertex, but that's what we found when we did that. Okay, let's do one more of those guys. These are the most difficult ones I think we will do today. So let's go ahead and look at one more of these. So we'll do number 16. Okay. First things first, let's go through our checklist. Is this equal to 0? Yeah, equal to 0, good to go. Second thing we need to check is what's the a value. Well, the a value is 7 right here, so it's not the quick, easy method. It's a longer method. So what we need to do is we need to take a times c, which is 7 times 4, which is 28. We need to find those factors of 28 that add to 29. So let's start 28 and 1, negative 28 and negative 1. We're already done. That's nice. So we've already found that. Now what we need to do is we need to pair these again. Sometimes it's easier one way than the other. I'm going to partner this 28 with the 7. So when I rewrite this, I'm going to go 7x squared plus 28x plus the 1x. If you look at that, we haven't changed the value because 28 plus 1 is still 29x plus 4 equals 0. Remember, we're looking for, when we factor that, we get those two like guys. That's what's going to happen. We're going to get two guys that are the same. So let's regroup. Common factor between 7x squared and 28x is we pull out the 7x. Okay, so now we got them grouped nice and neat. We're looking for the factors of 7x squared plus 28x. Factors of 7 and 28 are 7, and then remember we have 2 x's here and 1 x here, so I can pull out that x as well. What I'd be left with here is just x, because 7x times x is 7x squared. 28 factors 7 out, I'm left with 4. I only had 1 x and I factored that out, so I'm left with x plus 4. So remember, what we should have over here is x plus 4. Our common factor there, it was already x plus 4, so our common factor is just 1. So I'm just going to write that 1 there. Now we can factor these guys out, x plus 4, and when we do that, what we're left with is 7x plus 1 equals 0. Okay, so now we have to use that zero product property. This is the easy one. What value of x makes that 0? Well, negative 4 plus 4 is 0. This one, I'm going to do my little side equation over here. I'm going to go 7x plus 1 equals 0. What value makes that 0? Add 1. Sorry, subtract 1. So you get 7x equals negative 1. Divide by 7. So your solution there would be negative 1, 7. Kind of a goofy answer, but it works. So it's negative 1, 7. Okay, there's your solution. All right, let's move on to the next portion, is completing the square, which we are not going to do that. That's the fourth method to do it, and we're not going to look at that. We're going to move on to the quadratic formula. The quadratic formula written right there is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's the equation that we're going to use. What I said about this one is it's kind of nice because it works for everything. Even if it doesn't have a solution, you can find it using the quadratic formula. So that's the method we're going to use now. Alright, so let's go ahead and look at this. 2x squared plus 6x equals 5. We still have kind of the same first check. First thing we need to look for, is it equal to 0? In this case, no, it's not, so we've got to do a little bit of work to get it equal to 0. I just moved this positive 5 over, so I subtract 5 over. So I'm going to have 2x squared plus 6x minus 5 equals 0. Okay, so we're good to go there. Now, once we get that, we have the quadratic formula. We could possibly factor this just like we were. 2 times negative 5, that's negative 10 factors of that. If you look at that, are there any factors of negative 10 that add to 6? There's actually not, so this is not factorable, so we would have to use the quadratic formula. All right? So let's go on to this, the quadratic formula. If you want to do like we did when we were graphing these, A is 2, B is 6, and C is negative 5. You can write those right there so you see them. You don't have to, but you might want to get in that habit. So let's set it up, quadratic formula. X equals the opposite of B, which is 6, plus or minus the square root of b squared, which is 6 squared. I put it in parentheses here for that same reason. If I square a negative number, it's going to be positive. Minus 4 times a, which is 2, times c, which was at negative 5. Okay, and that's all over to a. Now a is 2. We've got to be very, 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 very careful with our negatives here because that's a big mess up on these. Alright, so let's go ahead. We have the opposite of 6, which is negative 6. Because remember, if your b value is negative, then that would be the opposite of a negative, which would be positive. Plus or minus the square root. 6 squared is 36. Let's do some quick mental math. What I like to do is get rid of my signs and take care of my signs first. A negative times a positive is negative. Times a negative, so I have two negatives. They're going to cancel out, and this is going to be a positive. Then we can do the math. 4 times 2 is 8. 8 times 5. 8 times 5 is 40. All over 4. So we have x equals the negative 6 plus or minus the square root. That's 76. If you have some good number sense, you probably know already that the square root of 76 is most definitely not a pretty number. Now, what I'm going to tell you to do now is let's just go ahead and go straight to decimal form. So we're going to take the square root of 76, and you can go ahead and do that as a decimal. So the square root of 76 is like approximately 8.71, 8.72. So what I'm going to do is go x equals negative 6 plus or minus 8.72. So I'm going to go 2 decimal places just to make sure I don't rounding doesn't affect my answer as much. Over 4. Now, we still have two answers because we have this plus and minus. So I'm going to split that up. I'm going to go negative 6 plus 8.72 divided by 4 and negative 6 minus 8.72 divided by 4. Now, when we do this, you've got to be very, very careful with your calculator work. You need to do this first. Negative 6 plus 8.72, which would give you 2.72. Divide that by 4. And then this negative 6 minus 8.72, which will give you a negative 14.72 divide by 4. Go ahead and throw that in your calculator. Now, if you wanted to use parentheses in your calculator, you could if you put parentheses around that stuff in the top. And what we would end up with is we would get 0.68 and negative 3.68. There's our two solutions. Now, those are by no means pretty answers, and that's why this equation was unfactorable. That's probably why we had such unpretty answers. Right? Now, I'm going to skip 26, 27. I'm going to hop down here to 28 just for room and time's sake. Let's look at 28. Now, first check. Is it equal to 0? In this case, no, it's not. So we need to go ahead and move that 8 over. So I'm going to go 2x squared plus 5x minus 8 equals 0. Now it's all set up, Pythagorean theorem. Now again, we could factor this possibly. Let's check to see if it is factorable. 2 times 8 is negative 16. Are there factors of negative 16 that add to 5? So we'd have 2, 1, 16, negative 1, 2, 2, negative 8, 8, negative 2. No, there are not. 4, negative 4, no. So this is unfactorable. So what's probably going to happen here is we're probably not going to have very pretty answers. Let's set it up. Again, if you want to do a equals 2, b equals 5, c equals negative 8, that's fine. Am I asking you, telling you to do that? No. X equals the opposite of b. I'm going to put parentheses just in case it was negative, plus or minus the square root of b squared, just 5 squared, minus 4 times a times c, all over 2 times a, which is 2 times 2. X equals, let's go ahead and simplify, negative 5 plus or minus the square root. That's going to be 25. Again, I'm going to take care of my sign. So I look at negative, and the negative here is going to be positive. So if we have two negatives like that, it's going to be a plus. And then that's going to be there, so that'll be 64. All over 4. Simplify one more step. And you can see how important showing our work is right here. If we don't show our work, we're most definitely getting lost. That's 89. All over 4. Again, a little bit of number sense tells you that the square root of 89 is not pretty. Square root of 81 is 9, so that's going to be just over 9. 9.43 is what I'm going to use. So again, now I'm going to go 9.43. So we're going to be approximate now, so we're going to put squiggles, negative 5 plus or minus 9.43 all over 4. Now if you want to go ahead and split it up here, so I'm going to make this one the plus, and I'm going to make this one the negative, the minus. There's your two answers. Again, if you want to throw this whole thing in your calculator, that is fine. Just make sure you use parentheses around those. If you do not, your calculator is going to mess up for you. When you throw that in your calculator, you get approximately, so we got our squiggles here, approximately negative 3.61 and 1.11. Remembering still, guys, what we are finding here is that parabola crosses at negative 3, 1, 2, 3, 4, negative 3.61 and 1.1. That is still where that parabola crosses, is what we're finding right there. All right. So if you have questions on this stuff, please, please, please come in and see me. Again, this is probably the most difficult stuff from algebra last year. So good luck, and again, you can see me in the morning or before or after school.